Time. All right. So yesterday we talked about calculating an inverse function, which is kind of like the reverse of it, right? We swap the x's and the y's, and then we solve for y. And a lot of those equations just kind of look like they're a bit backwards from the original function. Well, today we're going to look at the graphs of them, right? The physical representation of those functions and how it relates to the inverse. So the graph of an inverse function is going to be a reflection. Remember those in geometry? You have a line somewhere and you like reflect that shape or whatever over that line. Same idea. And you're reflecting it over the line y equals x, which is actually just your basic diagonal line. So if that's your coordinate plane, the line y equals x is like a perfect diagonal. It's got a positive slope of positive 1 over 1. Like I could rewrite this function as y equals 1x plus 0. If I put it in slope-intercept form, technically there's no y-intercept. It's 0, right? Because you're not adding anything to the end of it. And then the slope is 1. That's the number in front of the x, or 1 over 1. So up 1, right 1, up 1, right 1. And you get this pretty classic line on our graph. And so you're going to reflect over that diagonal line, basically. Nice thing is, to do this reflection, since it's always reflecting over that same line, what's really going to happen is we're going to swap the x and the y coordinates. So if our first function had a point at 2, 3, its reflection will have a point at 3, 2. You literally just take the x and y and just switch their positions. The x becomes the y becomes the x. And you plot that new point. What do you think? Can you handle that? I told you, it's an easy unit, right? This isn't bad at all. So, a lot of stuff to write here. So, if you just want to sketch a quick coordinate plane and draw this diagonal line and then these two parabolas, don't worry about the equations that I've got written there. Don't worry about the words up there. Just draw the coordinate plane, just real quick, the two axes, and draw one parabola kind of up at the top over the y-axis and one parabola to the right on the x-axis. And we're going to emphasize 3 points on this original parabola, this one up here. So you got the point 0, 3, 1, 4, and negative 1, 4. So I want you to at least put those 3 points on there. Make sure that you are close-ish to them, that they look reasonably close. Again, you don't have to have every little crisscross line. So if you see the blue, it's like a sideways parabola on the right. That's the reflection of it. If you reflect over a diagonal line, it actually kind of like looks like it rotates in a way. It's not going to be a straight up and down or left and right kind of a flip because you're reflecting over a diagonal line, that green dashed line y equals x. And so all that's really going on here is that you're going to switch the x and the y coordinates. So let's take this first point, 0, 3. The inverse of that point would just be switching the x and the y coordinates. So I'm going to plot the point 3, 0. And if I plot that, take a look on the blue parabola. It's right there. I'll use a different color to make it stand out. And that's the vertex, right? So when the vertex reflects over that green dashed line, it goes from 0, 3 to 3, 0. Okay, what about the other points? Negative 1, 4. Well, if I reflect that, it's going to be at 4, negative 1. And so that's the point, up there. And when I reflect that, it's going to go right 4 down 1, and you can see on our blue parabola, it's there right below the x-axis. And then that last point, 1, 4, would reflect to 4, 1. So right 4 up 1, that's the reflection of that point in the upper right. That's pretty much it. What do you think? Nice, easy lesson, right? Just like yesterday. Here, well, let's do a couple examples first, just to make sure. No, it's this easy. You're swapping the x and the y. For real. Can you do that? I mean, I'm not going to give you the coordinates ahead of time. You're going to have to, not yet. Put that down. You're going to have to identify the points yourself, but still, that's pretty simple, right? If I give you a graph with some shape on it, can you graph the inverse? We'll just find a number of points on there and make sure, like, when you're picking a point, don't choose a point like this, right? Because that's like a weird decimal. You don't know exactly where it is. Pick a point at an actual intersection, you know, like 4, 1, 0, 3. One other thing, I think this method of just swapping the x and y is probably the simplest way to do this. Another way, though, that's kind of unique, is if you take any point and you count like how far to the right it is to the line y equals x, like this was 3 spots, it'll be that exact same distance down instead. And it works for all of them, right? So like take this point way over here, count over 1, 2, 3, 4, 5. It's 5 jumps to that line. So if I jump down, 1, 2, 3, 4, 5 jumps down, and that's where that point would go. Okay, so that's like what the reflection is. It's reflecting, you know, whatever its x distance was will now be like its y distance from that line. And so the main thing is these two functions right here, which represent the two graphs, those are the inverses of each other, right? Like if I were to take the inverse of this, I'd subtract 3 and then square root. And check it out, subtract 3, square root. You know, so those are inverse functions of each other. And it turns out that when you graph them, it's just this reflection over that line because you're really just swapping the x and the y, reflecting over the line y equals x. Oh, one thing, I should put plus or minus there technically. Since square roots can only be positive, it'd actually only be that part of the parabola. But this piece down here, let me use a different color. Technically, that lower part would have to be the negative square root of x minus 3, because by doing this, is that graph there still a function? If you remember back to the vertical line test definition way back in Algebra 1, where he said if you take like a line or a pen or a pencil or something, and you move a vertical line over a function, if it ever crosses the function 2 times or more, it's no longer a function, right? So this is not a function, whereas this one is, right? That parabola only touches the vertical line 1 time ever. Here it doesn't, so it's actually 2 functions put together, a sideways parabola. You'll learn more about those next year in pre-calculus. Yay! Oh, speaking of next year, I didn't talk about course selection for next year yet, did I? No. That's coming up. So I do want to take a moment to talk about that with all of you, okay? So next year, I guess typically the progression of math courses in high school, this is just on average for the majority of students, this might not be your situation, would be Algebra 1 in 9th grade, Geometry in 10th grade, and Algebra 2 in 11th grade. All right, and so, you know, generally we have mostly juniors. Some of you might be sophomores, some of you might be seniors. Totally okay. This may not apply to you. But for those of you that are in 11th grade right now in Algebra 2, provided that you pass all the previous courses, which of course we're assuming you did, you've actually reached all your mathematics graduation requirements. You technically only need 3 years of math to get a high school diploma. This isn't a secret, all right? So don't be like, I'm done with math for the rest of my life. No, not quite. What you do next year depends on your goals, all right? If you know that after high school, you want to be the best warehouse stocker at Walmart, well, guess what? You probably don't need to take a math course next year. But if you're planning on going to college, and specifically, if you're planning on majoring in some field such as not just like math, but something in the sciences or the medical field or engineering or computers, you're probably going to want to take pre-calculus next year to stay on that math track, all right? The best thing to do is if you have an idea of what you might want to major in, or if you have a pretty good idea of which school you'd like to go to, perhaps, which college you'd like to go to, check with them to see what they would recommend, if they would prefer you to have pre-calculus on your high school transcript. If not, however, we do have a senior year alternative to pre-calculus that's not as math intensive. That course is called Transitional Math. I basically like to think of it as Algebra 2.5, right? It's not like a whole new course. It's going to cover a lot of the same stuff that we did this year in Algebra 2, but go into a bit more depth. All right, it'll introduce a few more concepts that we didn't cover this year. And the intention behind it is just to keep you familiar and practice with your math skills. Because if you don't do any math at all your senior year, and then you go to college, your college is going to make you take a placement test, most likely, for math to see, all right, well, where you took Algebra 2, but where are your math abilities right now, today? And based on how you score in that test, they'll be like, oh, you should take this math course your freshman year in college. But if you don't take any math for over a year, you're going to do pretty poorly on that, right? The more you practice something, the more familiar you are with it, the better you're going to do. But if you take a ton of time off, you're not going to be that great. So if you do poorly on that placement test, there's a good chance that your college will place you in what's called a remedial math course, which is essentially high school math, which you'll have to still pay college tuition for because the college is giving you that course. But because it's so low, you don't even get college credit for it, so it doesn't count towards your college degree. Don't get in that situation. Don't pay for a college course that you don't need, you know. So at bare minimum, take transitional math your senior year then. If you're like, oh, I'm going to go into the arts or something, you know. There you go, Gavin. And just think about what your future goals are, and then which of those two courses will be more relevant to you. But most majors is pretty clear. Like if they say, hey, you're going to need calculus, then definitely take pre-calculus next year, you know. Or if you enjoy math and you just want that level, by all means, take pre-calculus. That's fine. But if not, the bare minimum, take transitional. Yes, sir. Oh, good question. AP Statistics, completely different course. It's very useful mathematics. No matter like what field you did, being able to analyze something and make decisions based on statistics and analysis and data is very, very useful and relevant. So it's a very different course. There's not a lot of algebra in it, not a lot of geometry in it. It's kind of new types of math. That's pretty cool. So if you like looking at data and making decisions based on your evaluation of that information, then I think that's a good course to take. So some students will take both AP Statistics and pre-calculus next year. But again, as I mentioned previously, if you are planning on going to college, still take some type of math course that has some algebraic skills in it, whether it's Algebra 2 again, if maybe you didn't do that well this year. Like if you got D's, for example, you've passed Algebra 2, but you should probably take it one more time, right? So take Algebra 2 again to get those grades up. If you got C's or higher, that's what transitional math, it's for someone who maybe got like a C or a B in Algebra 2 and knows that they won't need to get to the calculus level in college. All right, that's who that course is for. Any other questions about math courses? Please don't sign up for Algebra 1 next year. You're all way beyond that. Or pre-algebra. Can you imagine, like, sometimes I always think out, like, what if I went back to high school right now and like was taking Algebra 1? How well would I do? I think it'd be so easy, right? But what if it's tricky? What if it's not? You know, it'd shatter all confidence, all beliefs. I'd be finished. All right, well, back to algebra 2. Boop. So here are your steps to graph the inverse of any function. That's just an example. These are the steps you're going to take. So if you forget what to do, just look back at this sheet. It's pretty straightforward. So you're going to reflect it over that line, y equals x. And so technically you don't need that dashed line, y equals x, but it's nice to use as a reference point to make sure that your final reflection is kind of flipped over that line, but it's not required. Then pick any point on your function, and please pick an actual like intersection point, you know, with an x and a y that's an integer. And then swap its x value and y value, and then plot that new point. And just do that a bunch of times until you see the shape. Obviously, you'll need more than 1 point. You're going to have to do at least 5, but you can do more than 5 points if you would like. All right, so pick a point, switch the x and the y, plot that new point. Very, very straightforward. All right, so I know you're not going to have a precise drawing of this in your notes, but if you just want to sketch a quick x and y axes, you know, just do something like this. Shoop, shoop. You can draw in that diagonal, make it a dashed line. And then you can just draw like some general curve. It doesn't have to match exactly, but just some type of a shape. Just to help you get the idea. And so pick a point on this line. So for example, I see a point right there. What's the coordinate at that point? Can you read the numbers from there? Is it clear enough? What is that coordinate? It's 4, 3. Right? So this is the point 4, 3. So then its reflection would be at which point? 3, 4. Yeah, not the most challenging thing of the year, right? So go to 3, 4, and put a dot. All right, let's pick another point right here. This point is 2, 1. Switch the x and the y. I'm going to go to 1, 2. Where else? How about right there? Pick that point. 0, -1. Its reflection would be at -1, 0. Going off to the left. Make sure you don't go up. Don't move vertically. You're going to move just horizontally for that one. Now, those are the only real points that I can see clearly on my graph. And you're going to have to kind of use your imagination a little bit, because if I just connected those three dots, I just have a line like that. And obviously that's not the reflection, right? That's not it. So just try to think of it, maybe even turning your paper sideways a little bit so that this green dashed line is straight up and down. So let me see if I can do that. And let me group this. So if you want to change your paper so it does look like a mirror, right, where that green line or that dashed line, y equals x, think of it as straight up and down and just reflect things left and right. And try to match it up. So I kind of see it's going there, then curves around, gets close, then hits that, and keeps on going off. All right, so it should look symmetrical. Does mine look okay-ish? Right, so try to do the same thing in your notebook. Try to make it match up over that line y equals x. And that's it. You've graphed the inverse function. Let me revert it. Oops. Back to its original orientation. And so that technically is what that reflection would look like. So that's the inverse of the function. Now we don't know what the equation is of that line, but we don't need to know what the equation is. We're just graphing the inverse of it. That's what the inverse graph would look like. We okay with that? Can I get some thumbs up to move on? Awesome. All right, let's do another one. Just draw a line with like a positive slope, make it above the x-axis. So just a real quick sketch. So we're going to draw our reflection line to help us see it. And so that's just a straight diagonal line, slope of 1, so it's like perfectly in the middle. So on your little sketch, you might have something that looks like that. So I want you to make sure that your red graph line crosses over this reflection line, so you can see, well, what happens when some points are on one side and some are on another side. I mean, it's still just, you're just flipping the coordinates, so it's still pretty straightforward. So I've got points like there, 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 and I'm going to reflect each of those. So on the far right, I have the point 4, 3. Its reflection will be at 3, 4. My second point is at 0, 2. Its reflection will be 2, 0. And last, I've got a point at negative 4, 1. Its reflection would be at 1, negative 4. So the important thing, I know this seems pretty straightforward. The one thing that you might get confused on is switching a number between a positive and a negative, right? When we say like flip it or switch it, sometimes you get confused and think, oh, do I flip the signs? And you don't. You keep the signs with the number, right? Like that point on the left was at negative 4, 1. Oops, I didn't plot that right. So its reflection is at positive 1, negative 4. So the negative 4, it's still negative 4 both times, right? I don't switch from a negative 4 to a positive 4. I'm switching its x and its y coordinate, but you keep the signs with each of those numbers. Now, since this original graph is a straight line, we can go ahead and just connect the dots. As long as your graph was precise enough, you should be able to connect those pretty easily. And just get your straight line like this. Oh yeah? Maybe your perception of it is just crooked. Does that look kind of straight? You know what? There. Is that okay? Come on! It's... You're... Yeah, I know, that wouldn't make any sense. All right, so there's your reflection. So just know that the intent of this was to show you that the function can cross that reflection line, and it's just like whatever was above it will reflect below it. If any part of the original graph was below that reflection line, it will now be above that reflection line. Ooh, what is that? That graph is called a hyperbola. We get to learn about that next year. So I'm just trying to show you, like, no matter how crazy your graph might look. So this has like a curved piece like that. Another one like that. And it's just the same idea. You take a point on one line. Ooh, wait, what about this? Look at that point right there. That's on the reflection line. Well, what happens when I reflect that point? Where does it go? It would stay there. Like, what are the coordinates of that point? It's 2, 2. If I flip 2, 2, we get 2, 2. The same thing, you know, because it's on that line y equals x, which literally means y is equal to the x value. So every point on that green dashed line, the x and the y coordinates are the same. 1, 1, 2, 2, 3, 3, and 4, 4. So any part of your graph that's on that line, even down here, will stay there. It's going to be on that exact same point. And there aren't too many other points here that I can use. So there's one at -1, 5. Its reflection is at 5, -1. Or this part there, that's at -6, 0. Its reflection would be at 0, -6. And so those are kind of the only points we have to work with. And so here's where, again, you've got to really use your visualization mastermind to try to think about, all right, what would that reflection actually look like? So if you want to slant your paper and think about reflecting over this line. And like if I start over here on the right, so I know, okay, so this, whoa, no, not that. What? Okay. So, like if I'm starting with my graph, I see that this is like below my reflection line. Its reflection would start above it. And that's like between 1 and 2. So its reflection will start between 1 and 2. So I can just, even though it's not an exact number, at a perfect intersection point, I can still kind of estimate, well, it would be somewhere around there. And then same thing with this, the end of that curve, which is between -1 and -2. So its reflection over here would be somewhere between -1 and -2. So I'm going to kind of go like this, hit one point, hit that second point, and then bring it over. So it doesn't actually look that much like a reflection because of the way the lines swap each other and flip-flop. So sometimes you have to get a little iffy. And then same thing with our other graph. So like this point here is between 0 and 1. So its reflection would be down here between 0 and 1. The other end of it is between -2 and -3. So its reflection will end between -2 and -3. Remember, this point is part of both of them. So I can kind of see from the X through those two dots, that other X, and just the general shape is just a curve, right? So you're just going to start here, curve, curve, boom. And there's your inverse function. What do you think? Are we feeling okay with this stuff? No, yes. Okay. Do I have any more? That's it. All right, we have 5 minutes remaining. Please grab out your Chromebook. Dun, 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 dun. (6.2) Graphing inverse functions. Identifying inverses graphically. So you're going to have different shapes. Some are lines, some are curves. And the directions say graph the inverse of the provided graph, and you must plot at least 5 points. So all you need to do is just like we did in our lesson. Find a point somewhere on your graph. So for me, I'm taking this point. Maybe just start from the left and work your way to the right, And so this coordinate, think in your head, -9, +2. Then go to the point +2, -9, and put a dot. You have to do that 5 times for each of these, okay? So then let's find the next intersection point. So I'm moving along, no, no, no. Okay, right here's another point. That's at -7, +1. So go to +1, -7. This is at -5, 0. So we're going to go to 0, -5. There. Now, they don't have to be in a row. I could pick a point like way over here. That's at 7, -6. So I can go to -6, +7. Or right there is the point 1, -3. So go to -3, 1. And once you plot your 5th point, it should connect your dots for you. And, look at that reflection line and see, if you did rotate this slightly, would it be a nice reflection over that y = x line? Hopefully it is. If it's a parabola, do the same thing. You're just looking for any points that have, exact integer coordinates. You're just going to swap each one. Right, so this is a -8, 0. Go to 0, -8. -3, -1. -1, -3. 0, -2, -2, 0. 1, -3. -3, 1. Doot, doot, doot. And draw your graph. That's it. So you have to finish this by Friday. Do you all think you have enough time between now and Friday to complete these? Like 6? Do you think you could do that 6 times before Friday? You did it during my lesson, cheater. You're doing your older assignment now? Okay, everyone, make sure you get your practice in. Again, I know these are easy topics. What you shouldn't do is forget stuff from last week. All right, make sure you practice the skills from last week still, since you have extra time, because you have a test coming up on Tuesday. Good luck. Bye, everyone.